Good morning, students. So we'll move on to the next standard, IEEE standard, that is 1901.2a. So up to now, we were discussing about the standards which are supported for the wireless based of communication exactly. Okay, so now we'll go for some standard, okay, which will offer the wired based communication strategies. Okay, so we'll see that what are the disadvantages we may face over here. Okay, how we can overcome those disadvantages, what type of physical layer changes we need to adopt, then what type of MAC layer changes we need to adopt, what should be the topology over here. Okay, then what are the security aspects, we'll see that. Okay, so while most of the constrained network technologies relate to wireless, IEEE 1901.2a 2013, we say wired technology, that is an update to the original IEEE 1901.2 specification. So we are having a proper specification or a proper standard called as 1901.2 as a version. Okay, but the enhancement for that, okay, we are adding few. Okay, that will be called as 0.2a exactly. So narrow band spectrum for low power, long range, and resistance to interference over the same wires, okay, that carry electric power. Okay, so here we are using the medium, which is the wire-based communication. Okay, so the wire what we are using, okay, so that is what we are using for carrying the electric power, okay, to supply the electric power for these devices, and the same wire we are using to transfer the narrow band. Okay, along with that, we can achieve the long range distance. Okay, we'll see that how we can achieve the long range distance. Say if you are based on a wire-based communication, then while traveling through the distance, okay, we may drop the quality, okay, using these kind of medium. Fine. So what we need to do, we need to go for some kind of a relay. Okay, like one device should receive the content, it should repeat the content again, so that we can travel the long distances. Okay, so here we are having one application, we call it as MDPLC. Okay, is often found in use case such as the following. So where exactly this .2a standard we can use. Okay, we are having the example in case of a smart metering. Okay, like in case of electricity, gas, then water meters. If you want to deploy for particular area, like a smart area, if you are calling, like if you want to read the electricity bill or electricity reading for a house, then we need to visit individual house. Is it? So such type of technique we are using daily life. Fine. Monthly once, a person from a MESCOM or BESCOM, he used to visit our house. Okay, and he will be noting that how many units we are consuming per month. Okay, according to that, what will be the charges? So he'll be calculating and he will provide the bill for us. So if you want to convert this complete system as a smart system, like from one location, if you can retrieve the information of all the houses of an area, okay, then we need to go for this NBPLC kind of or as 1901.2a kind of network over there. Okay, and also for reading the gas, okay, and also for reading the water meters exactly. Okay, if you want to read the water meters, okay, previously we used to have municipal or panchayat kind of water if you are provided. Okay, then we used to have some meters, fine, based on those reading, okay, we used to get the bills. Is it right? Okay, so there we can deploy these kind of technologies. Then distributed automation, in case of monitoring and controlling all the devices in the power grid. Okay, there we can use this kind of technique. Then public lighting, like this smart cities, then streets, highways, then public areas such as parks and all there. If you want to deploy the public lighting system, okay, completely automated public lighting system, then we can use this kind of. Then electric vehicle charging station, like if you want to recharge your vehicles. Okay, nowadays electric vehicles are more, okay, bike, then car, fine. Nowadays we are getting buses also. Is it? So if you want to recharge your vehicle or recharge your bus or anything, okay, then there also we can go for deploying these kind of networks. So you see, like we need to charge them. That's it. Okay, so for that we need to go for some automation. For there we can utilize this kind of system. Then in case of renewable energies also, we can use this kind of techniques. Okay, then standardization and alliances. Okay, so the IEEE 1901.2 working group published the IEEE 1901.2a specification in November 2013. The IEEE 1901.2 working group only looked at standardizing the NBPLC physical and MAC layer independent of the upper layers. So we'll see how we are going to upgrade our physical layer and network, physical layer and MAC layer, that is data link layer. Okay, so NBPLC is defined for frequency band from 3 to 500 kilohertz. Just observe, we are having a huge difference in the physical layer band exactly 3 to 500 kilohertz. Okay, it's a huge variation. Like why we are saying like 3 to 500 kilohertz. See, it means that it is not compulsory like the packet size, what we are communicating or what we are receiving, it should be fixed. It may vary from 3 kilohertz to 500 kilohertz. So here we are using some kind of application. You can just observe it. Okay, for utilities and all, we are having 3 different versions of frequency A, B, C, D. You can just observe the range 35 to 90, 98 to 121. 125 to 140, 140 to 148. Okay, then here array 1 and array 2 we are having. These are the different applications we can run over this platform. Okay, then 37.5 to 117, then 154 to 403. Okay, such type we are having. Okay, so these are the what some flexibility we can observe in case of a physical layer. Means here the packet size what we are transferring, it is varying exactly. Okay, we are not having a fixed kind of a packet size. So .2a supports a large set of coding and enables both quality and throughput. Okay, so the data throughput rate has the ability to dynamically change. Observe it very carefully. The data throughput can dynamically change depending on the modulation type. Okay, so we are having lots of different modulation techniques available. Okay, so it all depends on what kind of modulation technique we are using over here. Okay, so maybe like we may be having 5 different modulation techniques. All 5 may be having different like output rates. Okay, so this standard like .2a what we have, this is supportable for all those type of dynamic change in the packet size exactly. So the physical payload size can change dynamically based on control condition, so based on channel conditions in IEEE 1902.2a, 1.2a. So therefore max sublayer segmentation is implemented. So here the packets whatever we are going to get from the MAC layer, okay, that will be transmitted from the physical layer. That is obvious. Okay, but one thing you need to notice, so what information you are getting, right? What information you are getting from the MAC layer, okay, so that should be segmented because here we are having a strategy of what dynamically changing strategy we are having. Okay, so the packet size should be segmented, means it should be divided. See, I will take one example. If you are having 10 MB of information which should be transferred, okay, so if your network is able to transfer 5 MB per second or 5 MB per transition, okay, then the data what I want to transfer, it should be divided into 3 pieces, like 3.5, 3.5, 3 exactly. 3.5 plus 3.5, total 8 it will become. Okay, sorry, 6, 7 it will become. Okay, then later plus 3 means you can observe the difference in the packet size. First 2 was 3.5, last is 3 exactly. Okay, see here in one transition itself, we are having 3 different kinds of data format exactly. So our data should be segmented in such a format that physical layer should transfer the information safely over. Yeah, okay. So if the size of the MAC payload is too large to fit within one physical service data unit, PSDU we are calling it as in shortcut. Okay, the MAC payload is partitioned into smaller segments. Okay, so MAC payload segment is done by dividing the MAC payload into multiple smaller amount of data, that is segments, okay, based on PSDU size. The segmentation may require the addition of padding bytes, okay, to the last payload segment so that the final MPDU, okay, fills the PSDU exactly. Okay, means the payload or the packet what you are segmenting, right? As I mentioned, 3.5, 3.5, 3 exactly. See the difference. First two was 3.5, last is 3 exactly. Okay, so here if you are transferring 3 MB, okay, then we need to change the modulation again because 0.5 MB is the difference. So that what we will do is your MAC layer will stuck some W bits over here. Okay, padding bytes we call it as, that is actually meaningless. Okay, we are not retrieving it as a data. Okay, for transmission itself we will be considering it as a data. In the receiver set, it will be neglected exactly, that padding bits or it's a double bits what we are stuffing. Okay, so the MAC layer, when it comes for the MAC layer, the MAC frame format of IEEE 10901.2a is based on the IEEE 802.15.4 MAC format. okay, or a frame format, but integrating or integrates the latest 15.4e 2012 amendment, okay, which enables key features to be supported. Okay, so it is totally dependent. See, you can observe the figure. Okay, general Mac frame format of 1009.1.2 exactly. It looked also like much similar to the first standard what we discussed, like 8802.15.4 Mac frame format. Okay, but two things you can observe. The difference is the information element we are adding over here, then segment control we are adding over here. See, our frame or the Mac frame was beginning from the frame control, then sequence number, destination pan ID, such like it will be followed by these fields exactly. But here we are adding two things, segment control and information element for 802.15.4 Mac exactly. From where we are adding the enhancement, what we did for the 15.4 was 15.4e exactly. It is only for Mac layer. Okay, so some key features also we are adding over there. And also it is having ability, this Mac layer is having ability to manage the protocols exactly. Key management protocol also we are having. Okay, so the segmentation control field handles the segmentation or fragmentation of upper layer packets with sizes larger than what can be carried in the Mac protocol data unit we are having. Okay, so the MPDU what we are having, the Mac protocol data unit. Okay, if it is not able to fit, okay, with that, then we need to go for the fragmenting or the segmenting the content which we are receiving from the upper layer. Okay, that will be done by your segment control. Observe it very careful. Segment control is responsible for piecing or fragmenting the complete information into different pieces. Okay. Then when it comes for topology, yes, here also we are going for the mesh topology over here. We are going for a technique called as relay. Right? We are going to adopt a technique called as relay. Exactly. You can just observe this particular link. Okay, I hope you can observe. So this is the base exactly. Okay, this is the base. Okay, so from here, observe it very careful. To this particular cluster, we are having only one connection. So from here, we are going to broadcast or we are going to retransmit the information to these houses or anything. Okay, so this is what the mesh network. You see everywhere. You can observe here also we have one more link. Okay, from here we are going to connect for number of, observe it very careful, number of houses. See, this is a gesture of a layout. Okay, where we are having, see, this is a road, these are the houses. Okay, so if you want to connect, see, hop, 2 hops, then 3 hops, 4 hops, such type exactly. Okay, like we are having like from one point to many point, from many point to few more points. Okay, so such type of distribution technique we are using over here. Okay, so here we are having few points, use case and deployment topology or topology for .2a are tied to the physical power line. As with wireless technologies, signal propagation is limited by factors such as noise, interference, disturbance, no clear data, and attenuation. Okay, means reduction in value of the quality. When distance increase, okay, remember when distance increase, and if you're using the wire-based communication, then obviously the quality of service will be dropped exactly. Okay, that's why for the cable connection and all. Okay, so what we are using, you can observe for villages, we're not having a city cable connection. Is it right? Okay, they need to be dependent on a tower base or else the ETH or such type of a facility. But in the city limits, we are having a cable connection for our TV entertainment. We observe somewhere, okay, like in Bangalore and all, okay. In my city also, okay, we are dependent on cable connection. Like one service provider we have, okay. So we will be provided with some setup box, okay. So from that base station or from that service provider, we are having a common connection line for a complete area. Okay, so from that we are retrieving the signal exactly. Okay, but if it is the case for the villages, okay, we need to cable for long distance exactly. Then the information or the quality of the content what you are communicating will completely drop. Okay, so the quality of service will not be matched. Okay, will not be managed properly. So what we do, we are going for wireless based of communication. Okay, from through satellites. Okay, we are retrieving the signal for the receiver. That is what the Airtel or Tata Sky such type of receiver will be placing, that umbrella kind of receiver will be placed over the house. Okay, from there we'll be having the cable connection. This is right. Okay, because of what reason? Because of this reason exactly. Means wired-based communication. If you are adopting, okay, then we cannot lay the cable for a long distance. Okay, it should be for short. Because of that reason, what we do? See, from here we are transferring the information to this station exactly. Okay, from here we are retransferring it again. Okay, instead of having a direct transmission for individual houses. Okay, from this house to one base station to many example. Yeah, this is how we are establishing the mesh network for this particular technology exactly. Okay, then when it comes for security, .2a security offers similar features to 802.15.4g. Encryption and authentication are performed using AES. Okay, in addition, IEEE 10901.2a aligns with 15.4g. Okay, in the ability to support the IEEE 802.15.9 key management protocol. So here we are managing our protocols. Okay, for the encryption keys, whatever we are using. Okay, so that should be managed properly because the receiver and the information should be decrypted properly. Okay, so we will be utilizing key management protocol. Okay, to handle the encryption and decryption key exactly. Then some different exist. These differences are mostly tied to the physical layer fragmentation, capabilities of IEEE 10901.2a and include the following. So what are those? The security enabled bits in the frame control field should be set in all MAC frames, okay, carrying segments of an encrypted frame. Okay, so the security control field, okay, should be set in the MAC frame, okay, so that if you are encrypting the information, that will be helpful in the destination while decryption. Okay, if data encryption is required, it should be done before packet segmentation. Observe it very careful. Okay, data encryption is required. It should be, if it is required, it should be done before packet segmentation. Remember, okay, if 10 MB of information you have, before you divide it as 3.5, 3.5, and 3, it should be encrypted exactly. Complete 10 MB of information should be encrypted. Okay. During packet encryption, the segment control field should not be included in the input of the encryption algorithm. Okay. So after that only it should be added. On the receiver side, the data decryption is done after packet reassembly. So when the information is received by the destination, okay, before we go for once we are receiving, okay, the data decryption is done after packet reassembly. You see the three information what we are getting of 3.5, 3.5, and 3, it should be assembled, it should be converted as a 10 MB. Okay, then we need to go for decryption because while encryption also, we did the encryption for total 10 MB, not for 3.5, 3.5, and 3. Okay. So this is for now, students. So we'll meet with the next lecture, okay, regarding the next standard. Okay, so we left with 3 more standards, so which will finish the model number 3 exam. Okay, thank you, students. So we'll meet with the next session. Thank you.